Today we're going to work with solving this system of equations with elimination. Yesterday we worked with substitution, and that was where we solved for one variable and then substituted it back in to find another variable. Okay? Today we're working with elimination. If you'll remember back from a couple days ago, elimination is where we eliminate. Exactly right. We eliminate one of the variables. Okay? So as you're copying this down, please take the time to make sure your signs are correct. Even if you're copying it right straight from the book, right to your paper, or from your workbook right to your paper, just take the time to go back over and make sure your signs are right. One single sign. If I accidentally put this as a plus instead of a minus, one single sign can change your whole problem. So just be very cautious with that. Okay? Hello, Chad. Okay, ready? So, first thing we have to do is we have to decide, okay, if I'm doing this by elimination, which variable should I try to eliminate? So, we're going to have just a real quick conversation about which one in this particular case would be the best variable to eliminate. So, I'm going to think out loud for just a second for you. Fair enough?
Yes.
Okay. So, first thing I'm going to do is I'm going to look at the x's. All right, I got an x here, I got a 2x, and I got a negative 1x. Okay, so those are relatively low numbers. I like those. I already have a positive x and a negative x, so that says it's something good for me. And if I want to eliminate another x, which I know I'm going to have to do, I can just multiply this bottom equation by 2, and those x's will be eliminated. Okay, so then let's look at the y's, just make sure. I got a 4y, a negative 1y, and a 2y. That's also pretty easy because, yeah, I'd have to multiply this by a 2 to get this to eliminate, but then I can multiply this one by a 4 to get that one to eliminate, right? Okay. The z's, let's look at the z's. A negative 6, a positive 2, and a negative 4. Well, these numbers are a little bigger than the other two numbers, so I probably won't choose that, but if I decided to go for the z's, it's pretty easy to get from 2 to 6. I multiply this one by 3, right? And they're already opposite signs. Also, to get from 2 to 4, I just multiply this one by a 2 to get those to eliminate. So even that one, even though the numbers are slightly larger, that one's still pretty easy to eliminate. So if I have to decide between x's and y's and z's, because of the numbers that are already there, I'm probably not going to choose the z's. Does everybody see why I would not choose these? Okay, so between x's and y's, most of you would choose x's. Okay, that would be a good choice. If I was doing this problem all by myself on my homework, I would have chosen the x's. Okay, to eliminate. All right, so first things first, I got to eliminate the x's. And I got to eliminate the x's probably twice, don't I? Because look what happens. First of all, we know that if I combine the top one and the bottom one right away, aren't the x's going to eliminate? Okay, so let's combine the top one and the bottom one right away. X and negative x is what? 0. 4y and 2y. 6y. Negative 6z and negative 4z. Negative 10z, negative 1, and 5. 4. So that's all fine and good. That was nice and easy. But what did it give me? It gave me an equation with y and z. If I have one equation with y and z, what do I need? Exactly. I need another equation with y and z. Got to have at least 2 equations for 2 variables, right? So that means I have to eliminate the x again. So let's use the top one and the bottom one to eliminate the x again. That's easy. Why not? Oh, okay, we already used this, so I can't do it again. I mean, I could, but that would be just a waste of time, right? I've already done it. So we have to use a different combination of 2 of these 3 equations. I've already used the top and bottom, so I can either use top and middle or middle and bottom.
Middle and bottom.
Is there a better choice of the 2? Yes, there is a better choice. If I choose top and bottom, I've got to multiply the top by what? negative 2. That's all fine and good and easy. How many different places are there to make a mistake if I'm multiplying by a negative? A lot, okay? If I use the middle and the bottom, I have to multiply the bottom one by just 2, right? So you want to do that?
Yes.
Okay, so if I multiply the bottom one by 2, the whole thing, I get negative 2x plus 4y minus 8z equals 10. Right?
Yes.
Wait, give me a second.
Yes, ma'am.
I have to do myself there. So we use the middle and the bottom?
Yes. I'm using the middle and the bottom. This one, and now this one. This one came from that one, though, right? I took this bottom one and multiplied it by 2, and I got this one. Now I'm going to combine the middle and this one. Do I need to rewrite these for you, or are we okay with just lines? You okay?
I like that.
You like lines? Okay, good. So now I have 2x and negative 2x. 0, okay. Negative y and 4y.
3y.
3y. 2z and negative 8z.
Negative 6z.
Negative 7 and 10. 3? Right? Okay. Now what do I have? 2 equations with 2 variables, right? 2 equations with 2 variables. So now I need to start again. How many times have we done elimination so far? We did it here, we did it here, and now we're about to do it here, right? So 3 times we're going to do elimination. All right? What would you like to do?
Y.
Do you like to eliminate the y's? How are we going to eliminate the y's? Oh, negative 2, right? Multiply by negative 2? Okay? So I'm going to just rewrite this top one right here. 6y minus 10z equals 4. And then here I've got negative 6y plus 12z equals negative 6. Now when I combine them, what happens to the y? It goes to 0, right? It's eliminated. What happens with the z's? 2z equals negative 2. Z equals negative 1. What should I do with that z now? Where? Where should I plug it in? Like back over here? No? Like right there? Wouldn't that make the most sense? Either there or there, right? This one has smaller numbers and it's closer. It would be hard to make a dotted path up there. 3y minus 6 times negative 1 equals 3. Well, 3y plus 6 equals 3. So if I subtract 6 from both sides, I get 3y equals negative 3. So dividing by 3 on both sides, y equals negative 1. So after I found the z, I came here and I went right down there, right? Solve for y. Now I got z and I got y. Now what? I've got to find x, right? So let's talk about this for a second. Is there a smarter choice to plug this in if we're trying to solve for x? Would this be a smarter choice? It might be in some circumstances, right? Because the x is by itself, but it's negative, okay? Would this be a smart choice? It might be in some cases because 2 is a pretty low number, but this one is all by itself and positive, isn't it? Okay? Wait, am I going to get the right answer if I plug it in for this bottom one or the middle one? Absolutely. But we want to make it as easy on ourselves as possible, right? X plus 4 times negative 1 minus 6 times negative 1 equals negative 1. X minus 4 plus 6 equals negative 1. What is minus 4 plus 6? X plus 2 equals negative 1. So subtracting 2 on both sides gives me x equals negative 3. So I've got my x, I've got my y, I've got my z. So what is my answer? Negative 3, negative 1, negative 1. Is it right?
Why is it x minus 4?
Why is it x minus 4 right here, guys?
Because I multiplied 4 by negative
4 times negative 1 is negative 4. Good question. Is this the right answer? Yes, ma'am.
So I need to write down that x. How do you get that?
Yes, ma'am.
This is what I did last night on the homework.
Okay. While she's done writing that down, let's go back and look at this first equation up here. I want you to think with me. Negative 3 minus 4 is negative 7, right? Negative 7 plus 6, is that negative 1? Yeah, so that one's right. Okay, we got that one right for sure. Negative 6 plus 1 is negative 5. Negative 5 minus 2, is that negative 7?
Yes.
Okay. Almost there. I mean, if we get 2 of them, isn't that enough to say that's the right answer?
No.
No, it has to be all 3, doesn't it? Okay. Negative x, all right, let's see. So positive 3 minus 2, 1. 1 plus 4. 5. Oh my gosh. We are so smart. We know for a fact that this was the right answer. Okay? How do you feel about this? All right, let me ask you a question then. What if I combine these and I got 6y minus 10z equals 4? And what if I combine these and got negative 6y plus 10z equals 3? What would happen if I combine them? If this was negative y plus 10z, wouldn't the y's go to 0 and the z's go to 0? So it would be 0 equals 7. Does 0 equal 7? Will 0 ever equal 7? No. What do we do if that happens? We write no solution and go to the next problem. Okay? What if we combine and combine and combine? What if this was negative 6y plus 10z equals negative 4? What would it be then? 0 equals 0. Does 0 equal 0? Will 0 always equal 0? What do you think is happening there? So, something to think about is, if it's something that's not true, there's no solution. If it's something that is true, what do you think? All of the solutions. Okay? Does that make sense? All right, what questions do you have about this example right here? What questions do you have? Give me a thumbs up or a thumbs down or a thumbs sideways. Tell me how you're feeling right now. Okay? Good. I don't see a lot of thumbs down, so that's good. We can answer questions as we go. Deal? I'd like to give you the rest of the period to work on some of these homework problems. Can you handle that?
Yes.
On your mark, get set, go.